Welcome to Physics Hub. So today I am going to do some announcement. We are going to start a new series on our channel. So in this series I will be uploading assignments from all the topics of your CSIR-NET 2020 exam. Start with mathematical methods and then classical, quantum, electromagnetic theory, thermal statistical physics, electronics, solid state physics, atomic molecular physics, nuclear particle physics, everything. Okay, so I will try to upload 2 assignments for each of the subjects in due time, and this will be really helpful for the students who are taking preparation for the upcoming CSIR-NET exams. Okay, so in today's video we will be uploading the first part of mathematical physics assignment. Without wasting much time, let's start today's video. So the first question of this assignment reads like this. This is from dimension analysis. So basically I have tried to go according to the syllabus. Whatever is there in the syllabus, we have just tried to follow that. It's the mathematical physics syllabus starts with dimension analysis. So our first problem will be from dimensional analysis. The problem reads like this: pressure depends on distance as P equals to alpha by beta exponential minus alpha z by k theta. Okay, so the expression of pressure is given to you, P equals to alpha by beta exponential minus alpha z by k theta, where alpha and beta are constant, j is the distance, k is Boltzmann constant and theta is temperature. Then what will be the dimension of beta? And you are given 4 options. Now to solve this question, what we have to do, we first have to know that this exponential minus alpha z by k theta, this is your dimensionless quantity. So alpha z by k theta will have some dimension like this, m to the power 0, l to the power 0, t to the power 0, because this is dimensionless. Okay, so from here we can write the dimension of alpha equals to dimension of k into theta divided by z. Now what is the dimension of k? To find out the dimension of k, we are utilizing this E equals to kT, where this k is the Boltzmann constant, T is the temperature. So dimension of k will be dimension of energy divided by dimension of temperature. Okay, now dimension of energy means dimension of work. Work equals to force time displacement. So m l t to the power minus 2, this is the dimension of force. If you multiply length with this dimension, it will become ml square and divided by t. T is the temperature here, not time. The dimension of temperature is theta. So it becomes ml square t to the power minus 2 theta inverse. So you have got the dimension of k. Now you can easily put it here. So ml square t to the power minus 2 theta inverse, and this is the dimension of k, and dimension of theta we are keeping it as theta, and dimension of z. What is there? Z is distance. It is given in the question. So the dimension of distance L. Okay. So we are getting m L t to the power minus 2 theta inverse into theta is 0. So this is basically the dimension of alpha. Okay. Now what we have to do? We have to use the principle of homogeneity. Okay. So I am just keeping it and cleaning other parts. So just use principle of homogeneity. According to this principle, the dimension of left hand side will be equal to dimension of right hand side. So dimension of P will be equals to dimension of this side, okay, dimension of alpha by dimension of beta. And as I told earlier that the exponential is a dimensionless quantity, so we can write the dimension as m to the power 0, l to the power 0, t to the power 0. Okay. Now we have evaluated the dimension of alpha, so we have to determine the dimension of beta. Okay. The dimension of beta equals to dimension of alpha divided by dimension of p. Dimension of alpha is ml t to the power minus 2. Okay. Now dimension of pressure. What do you know? Pressure is some kind of force per unit area. Okay, that is force for you, force per unit area. Now dimension of force is ml t to the power minus 2, dimension of area L square. So it is becoming m L to the power minus 1 t to the power minus 2. Okay, so we will just put that value m L inverse t to the power minus 2. And what does it produce? It is producing m to the power 0 L square t to the power 0. And you see this is matching with option C. So option C is the correct answer. The dimension of beta is m0 L square t to the power 0. So option C is your correct option. Now let's quickly move forward to the next question. Okay, so the next question reads like this: the line integration over a dot dl of a vector field a of xy equals to 1 by r square minus y I cap plus x j cap, where r square equal to x square plus y square is taken around a square. See the figure of side length or side unit length and centered at x naught y naught with x naught greater than half and y naught greater than half. If the value of the integral is L, then which of the options will be correct? Okay, so let's draw it. This is x axis, this is y axis, and you have to evaluate the integration over a dot dl. Okay, where your a is given a of xy, it is given to you minus 1 by r square minus y I cap plus x j cap. Okay, this is given to you, and where this r square is also given to you, that is 1 by x square plus y square. R square is x square plus y square. So we have just put the value of r square here in this expression. The next, what is given to you? It's taken around a square. So let's draw the square. Okay, and it is in this way of side unit length and centered at x naught y naught. So let's say this is the center. This center is given to you as x naught y naught. Now we have to find out this value of this integral a dot dl. Now how can you solve this question? This question is very basically very easy. What you have to do, you have to utilize Stokes theorem. Okay, so apply Stokes theorem here. Stokes theorem. You have to apply it here. So Stokes theorem, what Stokes theorem does, it converts a line integral into a surface integral. Okay, so integration over a dot dl will become a surface integral curl of a dot ds. Now finding curl is very easy because you are already given the vector function a. Now let's try to calculate curl of a. Okay, so how do you find out curl? You just write the unit vectors I cap, j cap, k cap, then del x, del y, del z. Now we just write the components of this vector a. The x component is this minus y by x square plus y square. The y component is x by x square plus y square, and there is no z component, so it is equals to 0. Okay, now if you calculate the ith component, you see this 0 and there is no z dependency here, so it is 0. So 0 minus j cap, so this will go out, so del x of 0, this is 0, then this, there is no z dependency, so this is also 0. Okay, so what is remaining? K. So plus k cap. So if you do like this, del x of this, so it will have two terms, x and x square plus y square is there. So you can consider it derivative of u and v. Okay, d of u v, where u is x and v is 1 by x square plus y square. So first we are keeping this 1 by x square plus y square. Okay, del x of x is 1. Then minus 2x square divided by x square plus y square. Okay, 2x on minus sign will come, and on another x is there, so it is minus 2x square. Then minus, okay, minus plus del of we will follow the same thing. Okay, and on minus will come, this will give you 2y square divided by x square plus y square. Okay, now let's say this is k cap, 1 by this, so it will become 2 by x square plus y square, and sorry, here square term will come because we are taking derivative 1 by x square plus y square. Okay, so 1 square will come. So minus 2 into x square plus y square divided by x square plus y square whole square. So you can omit this x square plus y square and you can remove this 2. So these are basically same thing, so it will get cancelled. So this is basically 0. So curl of this thing is 0. So this is result is basically 0. So the line integral is 0, and you see in the option it is given that L is independent of x0 y0. So the value of L is 0, so it is basically independent of this x0 and y0, and it is correctly matching with option C. L is independent of x0 y0 and its value is 0. So correct option is for this question is C. Let's discuss the third problem. This problem is from differential equation. Let's read the question. Let y of t be the solution of the differential equation x plus 1 into dy dx, okay, minus 2y, this is equal to x plus 1 whole to the power 4. This is the differential equation given to you, and subject to the initial condition y at x equals to 0 is 1/3. Then what will be the value of y at x equals to 2? Okay, so we can easily solve this question. So we are just rewriting the differential equation. So dividing both the sides by x plus 1. Okay, so we will get 2 by x plus 1 into y. Plus this will become x plus 1 cube. So look, this form of differential equation is quite familiar to you. It is basically dy dx minus p of x into y equals to q of x. Okay, so I am just writing it in a bracket. So this is similar to the form which you know, dy by dx plus p of x into y equals to q of x. And for this kind of situation, we have to find out integrating factor to find out the solution of this differential equation. What is that formula? E to the power integration p of x dx. Okay, so e to the power integration p of x is minus 2 by x plus 1 dx. Good. Now what we can write it, just write it in this way, d of x plus 1 by x plus 1, and minus 2 will remain as it was. So we know that this is equals to integration of, it's like kind of dx by x, okay, d of x plus 1. So you can take x plus 1 as another variable. So let's say u, so du by u is ln u. So here it will come like this, ln of x plus 1. Okay, so we can take this minus 2 on the here on this place. So it will be give you 1 by x plus 1 whole square. How we can write it? Because you know that e to the power ln u equals to u. So if this minus 2 goes to this side, it becomes 1 by x plus 1 whole square. That is why we are able to write it. Now once integrating factor is written, the solution of this kind of differential equation is given by this integrating factor into y, that is equals to integrating factor into q of x dx plus some constant c. Okay, so here integrating factor is 1 by x plus 1 whole square, so y by 1 plus x whole square, and qx is this x plus 1 cube. So x plus 1 cube into integration factor 1 by dx plus c. So we can easily determine this. So y equals to 1 plus x whole square, integration of dx is x plus integration of x dx is x square by 2 plus c will remain. Now to eradicate, to remove this integrating constant c, we have to utilize this boundary condition or initial condition, y at x equals to 0 equals to 1/3. So I am writing it here. So just put x equals to 0 in this expression and y equals to 1/3. 1 plus 0 whole square. Then this 0 plus 0 square by this will be 2. 2 plus c. So we are getting c to be 1/3. Okay. So we got the value of c to be 1/3. So our solution is now in this form: y equals 1 plus x whole square, x plus x square by 2 plus 1/3. Okay. Now we have to find out the value of y at x equals to 2. Okay. So therefore y equals to, by just putting value of x to be 2, we can write it like this: 2 plus 2 square by 2 plus 1/3. So 2 plus 1, 3 square is 9. 9 into 2 plus 2, 4 plus 1/3. 9 into 13 by 3, 39. So it is matching with option E. So option E is the correct option. So guys, till now I have discussed 3 problems. So if you are liking the video, if you are enjoying the video, just give it a thumbs up right now. Okay guys, so before I go to problem number 4, I would like to tell you that I am also teaching on Unacademy. So if you are preparing for CSIR-NET exam, you can join me on Unacademy. Okay, I will be covering the whole syllabus of your NET exam. And guys, I take all the classes in English, so language is not a barrier in my class. Okay, and I will be covering the whole syllabus. So if you want to join our Unacademy classes, you can join using our referral code Physics Hub. If you join using this referral code, Unacademy will offer you 10% off on overall fees, and I will recommend you to take 6 months subscription. That will be sufficient for you. Now let's move towards the 4th question. The 4th question reads like this: the Laplace transform of f of t equals to sin pi t is f of s equals to pi by s square plus pi square, where s is greater than 0. Therefore the Laplace transform of t sin is. So you are given this function f of t equals to sin pi t, and its Laplace transform is also given. Laplace transform of f of t, it is f of s. This is given to you as pi by s square plus pi square, where it is also said s is greater than 0. Now we have to find out the Laplace transform of t sin pi t. Okay. So how can I do that? We know one formula: Laplace transform of t to the power n. Okay, t to the power n f of t, it is equals to minus 1 to the power n dn by dsn f of s. We know this formula, where dn by dsn represents the nth order derivative. Okay, so here n equals to 1, here t to the power n, t is t to the power 1. So minus 1 to the power 1, then d1 by ds1, so this is basically dds of fs. Fs is Fourier Laplace transform of f of t. It is given to you as pi by s square plus pi square. Okay. Now what next we can do? We can just take the derivative of this thing. Minus is remaining as it is, and pi is coming outside because that's a constant. Now dds of s square plus pi square, this will produce minus s square 1 by s square plus pi square whole square with a minus sign, and derivative of this thing s square plus pi square, that produces 2s, because we are evaluating the derivative with respect to s. So this is basically 2 pi s by s square plus pi square whole square. So it is matching with option C. This was a very easy question anyways. Now let's talk about the last problem. This problem is also from Laplace transform. The problem reads like this: which of the following pairs of the given function f of t and its Laplace transform f of s is not correct? So you are given here 4 options and you have to find out the incorrect one. So let's check the first option, f of t. F of t is some Dirac delta function. Then f of s equals to 1, it is given to you. So let's calculate the Fourier transform f of s equals to Laplace transform of f of t. I am just messing up Laplace and Fourier, okay, but we are mathematically correct. Laplace transform of f of t is f of s. This is equals to, we will utilize the main formula, that is equals to 0 to infinity this function f of t e to the power minus st dt, okay, and that is because this Dirac delta function is a function like this. It has got 0 value only except at t equals to 0. So from the basic definition of Dirac delta function, we know that delta of t equals to 1 when t equals to 0 and it equals to 0 otherwise. So this integration will exist only at the value of t equals to 0, okay. Just put t equals to 0 in the integrand. This is equals to 1 and delta at 0 at t equals to 0 is 1. So the first option is correct. Let's move towards the next option. F of t equals to 1, f of s equals to 1 by s. So this is from the standard formula. Laplace transform of 1 is 1 by s. This is also correct. Third one, Laplace transform of sin kt equals to s by s square plus k square. But you know that Laplace transform of sin is constant divided by s square plus k square. But here it is given s. So this is the incorrect option. So the answer for this question is option C. Option C is the incorrect option, and the last one, f of t equals to t to the power kt, okay. So although we have got our answer, but let's check for the sake of completeness. F of t, this is given to you t e to the power kt. So this exponential term just helps you to shift the thing, okay. So we can easily find out the Laplace transform of t, okay. Laplace transform of t is, here t means t to the power 1, so 1 by s square, okay. Now if we do Laplace transform of t to the power kt, so look, this will be 1 by s square and your s will be shifted by s minus k, okay, because of this exponential. So it will become 1 by s minus k whole square, okay. So in this way we can solve this problem. So in this assignment I have solved 5 problems, and in the next part I will be solving other 5 problems, and in this way I will try to give you assignments from each of the subjects of your CSIR-NET physics syllabus. Once again I would like to tell you that I am also teaching on an academy. You can join me on an academy if you are preparing for CSIR-NET exam, and I am taking the classes in fully English, okay. So you can join our class and I will be covering the whole CSIR-NET physical science syllabus. I will be giving you assignments, will solve previous year problems, and you know that Unacademy is a very good platform. I have already made a video highlighting the positive points about Unacademy, so you can watch those, you can watch that video, and if you want to join Unacademy, you can join Unacademy, okay. So if you have any kind of question, query or confusion, you can let me know in the comment section. I will try my best to answer them all, and this is all for today guys. See you in the next video. Bye bye.